Welcome to the On-Premise IT Podcast, the only podcast that dares to be both on topic and on location. My name is Tom Hollingsworth, and I'm a part of Gestalt IT. In each episode, we bring you the perspectives of a group of IT luminaries around a very specific topic, a premise, if you will, related to enterprise IT. I'd like to take a moment to introduce our guests for this episode before we jump into the premise for today's episode, starting with Avril.
Yes, my name is Dr. Avril Salter. I've been in the wireless industry for a little over 20 years. My Twitter handle is Avril Salter USA. You can also connect to me on LinkedIn.
John?
My name is John Kilpatrick at HyperGeek Wi-Fi on Twitter. I've been doing enterprise IT and networking for about 25 years, and I'm a CWNE number 414.
All right, and Ali.
Hi, my name is Mohammad Ali. I am CWNE number 375. I am a solutions architect for Avar, and I've been doing Wi-Fi for approximately 5 to 6 years.
All right, well, thank you all very much for joining us. Let's jump into the premise for today's episode. Now, as you can tell, we have a group of wireless experts here, so we're probably going to be talking about everybody's favorite thing that doesn't run over Ethernet. But we actually wanted to talk a little bit about security because it's a very present topic in today's enterprise. Thinking about all of the ways that our data is being transmitted over the air and being encrypted and making sure that only the right people are connecting to our Wi-Fi and making sure that it all works right. And it's always the wireless's fault when it doesn't work. Whether or not it actually is, the wireless gets blamed for just about everything. There's a lot of moving parts that go into securing a wireless infrastructure, and it's only been getting more and more complicated as the years go on, as we add more and more functionality. So the premise for this episode is that security isn't the Wi-Fi's fault. Now, John is the one who brought this up. We were having a discussion, and we wanted to kind of delve in here because you've had some recent challenges trying to work with security when it comes to Wi-Fi. So why don't you jump in here and take the floor and kind of give us an overview of what you've seen and the challenges that you're facing?
Well, I think when it comes to the enterprise environment, the infrastructure engineers are in the middle. On one end of the spectrum, you have the customer, your users, who want wireless to be fast and frictionless, as some people like to say. And on the other end of the spectrum, you have the security people who obviously want it to be secure, but they may not know what that means, and they may not know what tools they have to achieve that. The challenge becomes, whether or not you have a clear understanding of what the risk tolerance is and what the security environment is for the business. Because as an infrastructure engineer, I feel it's not my place to dictate that. My place is to take the risk policy and the risk infrastructure that they say, okay, this is what we're comfortable with, and translate that into technologies that can make that happen. On the topic of having to figure out how to make that happen, I would say that the biggest challenge is not the Wi-Fi infrastructure, but it is the client infrastructure. And when it comes to things like authentication, it's amazing how little the clients are able to tell you about why they're having problems. So that's the biggest problem I've run into, is not why is the infrastructure broken, but why are the clients broken? Why aren't they doing what they're supposed to do?
And it's kind of funny that you mentioned that because we have recorded a roundtable here at Mobility Field Day, and it seemed like clients just kept coming up. And when we say clients, are we just talking about wireless devices in my organization, laptops, mobile phones? Are we talking about IoT devices? Are we talking about a whole host of things that transmit without wires?
I would say it's all of the things, but what's been most surprising to me is the most capable of those devices, namely laptops, especially running Windows, are not able to really provide the teams who administer those with clear logs and clear diagnostics about why did 802.1x fail? Why are you not choosing the right certificate? Why are you not presenting the right certificate to the network? What don't you like about what you're getting back from the authentication server?
But 802.1x and certificates, those are not wireless technologies. Like, I've enabled 802.1x on wired networks before. I have to use certificates to do like VPN stuff. Why are you troubleshooting those things on the wireless side?
Well, I don't know if anybody else has noticed this. Please chime in if you have. But given that all of our authentication servers have the name of a network infrastructure vendor on them, it's Cisco ICE. It's Aruba ClearPass. It has Cisco or Aruba on it. That's a network thing. That's a network problem. Even though it's a server running an application, and you may have an application support team that supports a lot of applications from a lot of vendors, somehow we seem to end up being responsible for infrastructure that comes, software that comes from the infrastructure providers.
So it's always the network's fault, too? Welcome to our side of the fence, John. I appreciate you joining us here on the It's Not the Network this time.
So back in the day, before my wireless days, I was very much on the network side and security side. And from what I can say, it's always going to be the fault of like whatever's at the edge. That's how I kind of feel like it. So before for example, one company I worked for, there was Wi-Fi. We were hardwiring everything. Every single client was literally hardwired. So it was always the network that if somebody could not log on or they were typing the wrong password, that was the network's issue. And now it's the Wi-Fi that has become the edge, so it's always going to be the wireless's fault. If the radius server is not working, DHCP servers are not working, DNS is not working, it's going to be always the edge.
Avril?
So I have a slightly different perspective, as always, right? So when I think of wireless and security, not just Wi-Fi, but all of the other technologies. We've got so many different types of devices now connecting to our network that we need a variety of different security solutions. There's not just one solution. There's not one way of doing it. And so we've got a lot of complexity coming into there. And I think somehow we have to sort of segment it in some way that we can still provide the appropriate level of security for that kind of device, that kind of access, whatever that device is doing. And so there isn't a way of saying, there's one solution or one ideal approach, but it's a mixed bag of things that we have to deal with now. And so, for instance, if I say the IoT world that we're seeing now, why would you do encryption at the wireless layer? Why wouldn't you do it at the application layer? It would be much more efficient. So it's really not a wireless issue. It's really an application issue, for example.
But it's also interesting that you bring up the fact that IoT has a bunch of different challenges. And I was actually talking to DigiCert about this a couple of years ago when I went to RSA. Do you know how long it takes to factor a 2048-bit key on an IoT device? The timeline can be measured in centuries because it takes forever for them to be able to process that with the lowest cost CPU available to them. And so they're finding ways to do things to offload that. But one thing that comes back to, and I think John kind of illustrated this a little bit, we're doing standards-based security. Years ago, we wouldn't have had certificate-based encryption. We wouldn't have had 802.1x. Somebody would have created TACAX-W, which is a proprietary implementation of TACAX that only runs on certain wireless devices, and you would have had to type usernames and passwords in when you get connected to the network. So I think that a step forward has been made that we're doing more standards-based security profiling, security authentication and everything. But the challenge is that when we apply it to a medium that is not standardized to our liking, because it's Wi-Fi, it's not an Ethernet cable. I can't predict what it's going to do, that it creates those issues. Something as simple as the authentication server not hearing a response in a specific amount of time and saying this client obviously must be rogue and trying to do something it's not supposed to, when in fact the problem is that someone started a microwave oven right next to the AP and the retries are taking a little bit longer.
Well, I'm going to kind of piggyback off something Dr. Salter said, and that and it kind of triggers me a little bit, but zero trust is a very hot topic these days. And for me, I think that the industry has lost the plot completely. Hot take incoming, hashtag it. Zero trust means your applications are secure enough to be exposed to the open internet, and that your RBAC is built into the application, and that everything, you don't need any network level security. Your application is good no matter whether I'm at a Starbucks or at your office. And that requires your enterprise application engineers to support that model and to write applications differently than they used to, but they don't want to do that. So they continue to push network security down to the network layer. They try to use IP addresses as tokens, all these things that are not a very good idea from a security perspective, because I'm sorry, but the applications are not secure. And so the network is expected to secure them. I think that the Beyond Corp Zero Trust model works so much better when your applications are secure. And so we're trying to help put our finger in the dike for applications that are inherently insecure.
I would like to once again welcome you to the Old Network Curmudgeon department, where we talk about the fact that applications that run on our infrastructure have inherently been crap sack for so long because they just need a minimum amount of functionality. Things like vMotion, things like Next Hop Reachability Protocol, because we can solve those challenges in the network, whether it's creating encrypted wireless transmissions and all kinds of stuff. And now we're at a point where we can't sustain that anymore. Avril?
So I was going to say, and coming back, Tom, to your point, the standards that we have in the industry are all defined at different layers. Mm-hmm. And then the IT has to piecemeal a solution between those different layers for different business problems. There isn't an overall network security architecture, or even right up to the application layer. It's all piecemeal. And I find that, I don't know what the answer is, but I find that really difficult to implement and then say, how do you secure the whole thing?
Well, it's kind of funny that you mentioned that, because when we at Security Field Day started looking at some of the very first zero trust network architecture implementers that were kind of in a startup level, it was ironic that they all had the same end goal, but they all reached the result with such wildly different technology that wasn't applicable to anything else. One of them used Windows Firewall as the method for providing zero trust. Another one could only do it inside of virtual machines because they actually bridged the VNICs and were inspecting the traffic as it flew across. And you guys should all be shaking your heads because that ain't gonna work in wireless, and we know that. So you're right, we have a goal. We're gonna try to implement something to get to that goal and worry about standardizing it later. And that's been the kick the can problem down the road for a number of years. So how do we solve that? How do we make that technology more applicable to what we're doing? Because to Ali's point earlier, the reason why the wireless is at fault all the time now is because when's the last time anybody plugged an Ethernet cable into anything that wasn't an AP? If you have to think, if you need to count on your hands, I totally understand.
Well, I'm trying to make sure that my responses are appropriate and I just don't go full off rant hinge.
No cursing. How's that?
Well, even that may not be enough. But I think that part of it is, to be honest, it comes down to business alignment. If we have been solving this problem for so long, and we have unfortunately become so good at it, if you're good at your job, that it's hard to convince the business to invest in securing the applications and worry less about securing the network. It's a money thing, right? It's going to be like, well, if I need to train my application developers or, refresh my application development team, or do I just continue to ask you guys to pull some, weird, crazy solution out of somewhere and deploy it, then what do you think a responsible business is going to do? They're going to do what the cheapest solution is possible. That's what.
Fix it in the infrastructure, and that way I don't have to find a brand new Python jock that wants twice as much money to figure out how to implement TLS version 1.3 in all of my applications, because evidently that's really hard.
Not just that. I mean, if they have to refresh the application too, right? I mean, there's a larger effect to that, right? That they have to.
Agile development, man. There's a new version coming out next week.
I work for a company, and it was an application that consistently would have the same exact issue, and it was a very simple issue where customers would actually send a user ID, for example, in a specific format, and if it's not the specific format, it would actually error out, and I would always have to do PCAPs to show the issue. Well, I think if it was a simple fix, I'm like, well, why can't we just not make an application where users are forced to kind of, stick to that format?
Set a standard that we're all required to do?
Yeah, exactly.
Have you talked to people who write down MAC addresses recently? Because but that's something simple. Think about all the different ways that you can write down a MAC address.
Yeah.
There's a Python library that solves that for you.
There was actually a company that solved that issue in a device that munged all of the MAC addresses and put them in a standard format, and I loved it. Shout out to you, Derek Winkworth. I love you, buddy. But ultimately, that's a very small solution to a bigger problem, and we talk about this all the time when it comes down to things like standards. You're going to do it this way. Why do I write an IPv4 address in 4 dotted octets as opposed to writing it as a decimal number? Because somewhere along the way, someone said that's how you have to write it. And that's the only way you're going to write it.
AS dot. Oh, I'm sorry. So there, and for anybody who didn't catch the reference, there's two different ways you can write a big ASN, and there's AS dot, and then there's just writing it as a single big number. So not even then, there's not always agreement. The thing that interests me the most is that when I look at what I do day to day, and when I'm working from home, most of the work that I can do, emails, Jira, calls, all of that I do without connecting to my company's VPN. And I think that part of what I'm, the reason why you're seeing applications move to the cloud, and unfortunately, I don't know if SaaS is a good thing or a bad thing from a financial perspective, but applications are being replaced with applications that are inherently secure. And maybe that's the answer, that at some point, when a business has moved all their applications to a cloud native or cloud ready platform that is inherently has these RBAC controls built into it, then we can go, well, do you really need all these access lists anymore? Because this could be a Starbucks network for all you want. And that's what a lot of CIOs want. They want the Starbucks network at the office. It's very high performant, but there's no security. It's not trusted.
Get the man in Cupid doll because he said the magic word, cloud. Cloud was a huge disruption in the way that we do infrastructure, totally. Now, obviously, you can point to virtualization, you can point to storage, you can point to any one of a number of things that were massively disrupted. But we're also starting to see this from the networking side, and maybe not as much from the wireless side because that's kind of an edge-focused mentality. But the idea that we're not going to build any of these clever hacks into the infrastructure in order to solve these problems. You want to do it? This is the way we support it. You want to secure your data communications? We're not going to have you tunnel VPNs all across our network to secure that traffic. You have to use certificates to do TLS encryption to protect that traffic. And I think it's kind of funny because when we think about something like, WPA3 and how it was trying to protect those initial preambles and trying to encrypt the client to AP communication to set up the encrypted network and how we were so worried about that. And honestly, depending on what you're using, whether it's Gmail or Salesforce or Jira or Terraform or whatever it is, ultimately doesn't matter because you capture a little bit of that first part, and even if you can crack the entire packet with it, the data that's writing over it's encrypted anyway. You're not going to be able to do that unless you intercept the session key. So I mean, did cloud finally invalidate all of our worries and say application developers do better because we're not going to support anything other than these things that we've built in?
If we take that premise and say, yes, that's possible, then the only difference between connecting with a wire and connecting wireless is it comes back not so much to the access authentication piece, but comes more towards the eavesdropping, right? Because that's the key distinction, I think, because when you apply for access, when you do data protection, integrity checks and things, all of that can be the same in both environments. So then it comes with the major difference when you talk about security and wireless together. And going back to your premise, it's not wireless as forward, it would be eavesdropping, right?
And I would say that your aversion to eavesdropping strongly depends on what your experience with being eavesdropped upon is. I would say that I push for MACsec, for example, in my environment more than others, because I was at one of the two companies that were the targets of Project Muscular or whatever it was called, and go look that up on Wikipedia, but basically nation states were eavesdropping, using microbends to eavesdrop long haul links between data centers. And one of my company's data centers were among those targets. And so now I'm like, MACsec all the things, encrypt all the things. If I don't have to because I trust all the applications, great. But even then, the eavesdropping thing, it's like, well, I'm always going to be inherently for encryption at the access layer because I don't trust anybody anymore.
So let's take it down to a different level because Dr. Salter is absolutely right that eavesdropping is a huge problem, but not in the intentional eavesdropping kind of problem, but in the incidental eavesdropping, because Ethernet and Wi-Fi are all based on the same premise that they're very chatty protocols, that they broadcast everywhere. And just like any other kind of thing, I may unintentionally hear about a broadcast communication intended for another node on the network and not realize it. And I can collect that data. someone who's very smart and knows how to span the right link on a switch can get a lot of data very quickly. And that's one of the things that Zero Trust was kind of designed to fix, was I'm going to effectively create barriers in my Ethernet that will not allow those broadcasts to kind of move around, whether it's using encryption or something else like that. But I'm going to ask the wireless experts, could you do something like that in wireless? Wouldn't it inherently break the ability of the devices to listen for chatter on the network if they can't hear anything else?
Yeah, so in wireless, you have to be able to find the network, right? So you have to be able to listen to some of the control and the signaling. It has to be exposed, right? But yeah, it's interesting. I think when it comes to, and that does expose your network. And then the question is, you just, what you're exposing there is just the wireless connection. You're not necessarily exposing what's beyond that in terms of your exposure to the core network, switching and things like that. I think that's still protected. That information doesn't go over the air. And the other thing that I think is interesting to note is if you look at user data, it's actually really difficult to sniff it these days because of beamforming, and you need a very sophisticated radio, and you need to be in the right location, not just close, but you actually have to be, almost intersecting the beam, if you like. It doesn't quite work that way, but conceptually you can think of it that way. And if you intercept it, well, the RF pattern changes and the beam moves. And so, poof, you've lost the data again. So it actually is getting really difficult to eavesdrop user data unless you can force the network not to use those features, right?
Well,
Which again is a level of sophistication you're probably not going to see.
Yeah, so I mean, security is a layered approach, right? So, if somebody can get to our closets and plug something in, I mean, obviously we got bigger problems that we need to deal with.
Or someone can drop malware on a computer.
Or somebody can drop a malware. Or in the wireless side, I mean, we do need to kind of see the network that's being broadcasted so we can connect to it. So there would be a security option right there. Now, if somebody is actually inside our building with some very sophisticated equipment, obviously, again, we need to kind of pay attention to our physical security too, because again, that's kind of, I would say, maybe like a layer one approach, right? We need to secure that. And if you don't have that secure, well, there's bigger problems that we're going to have to deal with. And then you go to the second layer and third layer, and you secure all these different layers, block east-west traffic possibly, I mean, if that fits your network and design. Some of these approaches can actually help.
Well, I think that there's also the question about while getting user data is hard, it's just a question of what kind of data disclosure do you consider to be a risk. Mm-hmm. I had a conversation just this week with some members of our security organization, and if I broadcast the same ESS ID at every office, and someone can drive by my headquarters and go, oh, that's his company's ESS ID. And then you see that ESS ID somewhere else while you're war driving or just intentionally, oh, I didn't know that office belonged to them. I didn't know they were in that site. I didn't know they were in that building. That's a risk. How do you mitigate it? Could you do a unique ESS ID per site? Okay, well, theoretically you could, but now if you're managing wireless profiles on your client, now you need to give a client like a profile for every possible office. There are some inherent challenges to wireless that are going to be based on the very fact that I may not be able to decipher the data, but I'll even be able to detect the energy. You can't stop me from detecting the energy the RF waves that you are broadcasting. So again, it comes back to what is your risk profile? Are you comfortable, for example, with somebody being able to fingerprint all your sites by seeing, the network can be broadcast, or are you going to change it because, well, this site's maybe a little sensitive and we didn't want anybody to know that we're there, so we changed the network name, stuff like that.
So I'm going to give you all a platform for just a moment. You now have the ear of all of the security professionals on the planet, and you need to help them understand that the security issues are not just the wireless's problem. How do you explain to them succinctly? What is the one thing that you wish you could tell them that helps you guys work better collaboratively as a team, that we're no longer throwing these problems over the fence and saying, hey, it worked fine in the SOC, and I don't care what happens when it gets to the NOC, WWOC, whatever we're going to call it. What do you want to say?
I would say more collaboration, standards, follow them, work together to actually create those standards actually for each layer, so you can actually secure your whole infrastructure from applications to the edge and beyond that.
I would say that I can help the security people understand what the protocols are, what they can do, what security features we can offer. It's up to them to come back and say, these are our requirements, these are what we need to feel secure, because it's, at the end of the day, it's an opinion if it's not a standard like PCI or whatever. So they need to kind of help understand the risk and help set the risk tolerance, and then trust us to go, okay, well, here's how these features address your risks. And maybe, it's funny, I was literally told, well, wireless is just inherently insecure because it just is. And I'm like, okay, but I can walk into the lobby and plug into a switch port and get on a network. And so I'm not sure that's a true statement. So maybe not have an inherent bias against wireless and work with us to help you understand what protocols we can bring to the table to secure things, and you help us understand what does going too far look like.
From my perspective, the thing would be understand that our market is moving where we have to have a range of different devices. We can't put a certificate on every IoT device. It's just not feasible. We've got to have a range of solutions. There are great security solutions defined at every layer from a standards perspective. What we're missing is the guidelines and best practices to support our different business needs. And where those best practices help us with the solutions not only over the air link, but right across the layers, all the way up to the application layers that we've been talking about in this session.
So it sounds like security hasn't gotten any easier, no matter whether we're transmitting it over a 10 megabit Ethernet circuit or a Wi-Fi 6E communications link. We're always facing the same challenges. We still have data that needs to move. We need to make sure that the people who are supposed to get the data get it and no one else can see it. But the methods that we use to do that are ever changing, whether it's something as archaic as a VPN or something as hot and exciting as zero trust. But the principles and the methods that we use to do it are still very much the standards that we rely on, whether they're certificates or some form of encryption. And those standards are dictated to us by business policy. We must do this. This can never be leaked outside of the organization. If you are in a coffee shop, you must do these things to stay safe. And if you are working on any kind of infrastructure, whether it be wired, wireless, or any combination thereof, you need to make sure that you're having those kinds of conversations with your security team. I understand that the security team is the department of no on many occasions, but they're the department of, I don't think that's a good idea more often than not, because they're working off the information they have from the policies and guidelines that they've been told. And if you can find a common ground, if you can collaborate a little bit and find a way to implement good security policy while adhering to the guidelines and also making your edge connectivity solution fast and frictionless, I think you'll find that not only will you be happier and your security team be a whole lot less anxious about everything, but your users will also be happy too. And more importantly than anything else, you won't make the news. That will just about do it for this episode of the On-Premise IT Podcast. I want to thank everybody for joining. If you would like to check out the episodes of the On-Premise IT Podcast, make sure you head over to our website, gestaltit.com/podcast. You can also subscribe to us on our YouTube channel at youtube.com/gestaltitvideo or in your favorite podcast application of choice. We put out an episode about every 2 weeks, so stay tuned for more great stuff coming your way. And if you have a premise that you'd like to suggest that we can debate here, make sure you tweet at us. We're on Twitter as @OnPremiseIT, and yes, we are using on-premise correctly. We will see you at the next episode. Until then, thanks for joining in.